Hello. The streets of the nation's cities and towns are an important part of the livability of our communities. They should be for everyone, whether young or old, motorist or bicyclist, walker or wheelchair user, bus rider or shopkeeper. But too many streets are designed to accommodate speeding cars, or worse, create creeping traffic jams. Now in communities across the country, a movement is growing to complete the streets. States, cities, and towns are asking for road networks that are safer, more livable, and welcoming to everyone. Instituting a complete streets policy ensures that transportation planners and engineers consistently design and operate the entire roadway with all users in mind, including bicyclists, public transportation vehicles, and riders, and pedestrians of all ages and abilities. As highly skilled professionals, you can respond to any design challenge. Now more than ever, we need your problem-solving skills to help deliver a future Tulsa that matches the safety, efficiency, and quality of life that Tulsans deserve and expect. The recommendation to synchronize land use and street design is found in our comprehensive plan. A simpler but just as important idea has been carried forward by Tulsa's Complete Streets Resolution, which directs us to accommodate several forms of mobility on every project. Less than half the population of Tulsa drives, so it seems fitting and appropriate that streets should accommodate more than just drivers. This doesn't mean a bus stop on every corner or a bike lane on every street, but it does present new challenges to you as a designer. In concept and in practice, different forms of mobility will be moved to the forefront in different situations, and we will be far less willing to accept trade-offs that put pedestrians and cyclists at a disadvantage. What makes a street complete will vary from project to project, and the Complete Streets Procedural Manual will give you the tools you need to figure that out. Complete streets is a relatively new term for an idea from decades past. Long before extensive regulations and requirements that favor rapid automobile movement began dictating street design, streets were built and developed to serve the destinations surrounding them. Some of the greatest streets in America still maintain this centuries-old character. Complete streets are streets designed for everyone, with safe access for pedestrians, bicyclists, motorists, and transit riders of all ages and abilities. There is no single design for a complete street. Each one is unique and should relate to its surrounding community context. This is in contrast to incomplete streets, which are designed with only cars in mind and makes alternative transportation choices difficult, inconvenient, and often dangerous. CSS, or Context-Sensitive Solutions, is taking the concept of complete streets and applying it to roadway cross-sections during construction, reconstruction, or rehabilitation in a suitable and appropriate manner. CSS uses many features like the context and character of an area, future goals for a corridor, and the future need for different modes of transportation to create a realistic and compatible design for the area. However, there is a difference between complete streets and CSS. The CSS process is used to determine if and to what degree complete streets is appropriate for a corridor. The CSS approach helps to guide thinking for the long-term goals of a corridor. Complete streets may offer many of the benefits that you already know and seek: increased road capacity, decreased travel times, and enhanced safety. But it often arrives at these benefits in new ways. Typically, if road builders wanted these benefits, they'd most often consider adding a traffic lane. But with complete streets, you might consider improving a sidewalk or bus stop or adding a bike lane. Every person who chooses these other modes of travel is one less driver on Tulsa streets, which reduces congestion and extends the service life of the roadway. Tulsa's current project development process formally begins with a project being identified and funded. Once funded, the design process is fairly straightforward, where design phases follow a 30, 60, 90, and 100% completion. The major street and highway plan establishes the street hierarchy and associated possible cross-sections, with right-of-ways indicated. Tulsa has developed a new project development process that bridges the gap between long-range planning and final engineering. Complete Streets Procedural Manual provides the city with the needed tools and procedures to make this transition seamless. Historically, transportation infrastructure has been designed, funded, and maintained to react to existing congestion by adding capacity. Experience across the country has shown the shortcomings of this approach, which relies on taxes and bonds to fund the infrastructure required by projected travel demands. Changing this approach is at the core of infrastructure reform initiatives at the national and local level. In short, the public sector can no longer depend on consistently raising the substantial funds required to build its way out of the present, let alone future congestion. Building better roads along with real alternatives to driving can change the problematic patterns that impair communities' quality of life. Congestion is just the most visible symptom of the underlying problems. The updated Complete Streets design and implementation process is outlined in Chapter 3 of the CS Procedural Manual. A useful flowchart graphic, Figure 3.1, has been provided that walks through the many necessary steps to achieve the most desired result. This graphic illustrates the process starting with a proposed project at the project initiation stage, culminating with the coordination of a multidisciplinary project team. Street design alternatives are developed and evaluated during the conceptual design phase, and with proper public input, this leads to a final design phase. With funding and complete construction plans in place, the process moves to the implementation stage. After the implementation of a complete street design, performance measures are used to provide further evaluation. The first step is the project initiation stage. Complete streets projects arise in two basic ways, either initiated because of needed street work or initiated by private development projects. A project should first be identified as either a utility-related project, a private development project, a capital project, or a minor maintenance project. While there are similarities in how these projects are conducted, the initiation and planning processes are different. For instance, a utility-related project initiated to replace water, sewer, or utility lines may be considered as an opportunity to introduce complete streets elements if the project length is significant. A 30-foot-long mid-block replacement of a water valve would not be a viable candidate, but a 3-block-long sanitary sewer line replacement would likely create a positive opportunity to add complete streets elements. In the case of private development projects, whoever initiates and sponsors a complete street project determines the initial review and approval process by the City of Tulsa. Some projects may have matching funds from state, federal, or local sources, while others are funded 100% by the private sector. Capital projects are roadway and reconstruction projects that are typically placed on the city's capital improvement plan. The scope of these projects is usually large enough to allow for consideration of planning and potential implementation of complete streets elements. Finally, minor maintenance projects such as restriping or resurfacing roadways should be evaluated as opportunities to introduce certain complete streets elements. Since these maintenance plans can be sporadic based on roadway conditions, they may not be appropriate for full complete streets projects, but can still be instances to introduce planned bike facilities or new multimodal features. After determining the type of project, all available data should be assembled to best inform the street design process. This should include both traditional thoroughfare data as well as information about the contextual environment. Designers of complete streets must balance roadway characteristics, the context and land use of an area, priority design elements, and the construction, operation, and maintenance costs associated with the improvements. The street context can be determined by referring to the comprehensive plan vision map as well as evaluating local area plans, existing land uses, existing zoning, and development proposals. The vision map is provided in Figure 3.1.3.1 in the manual. The Major Streets and Highway Plan, the MSHP, should be used to define the correct functional classification. The most current MSHP can be found on the NCOG website. The City of Tulsa has worked with NCOG to integrate the street design concepts from the comprehensive plan into the Major Streets and Highway Plan and has designated a series of context street types into their adopted plan: main streets, multimodal streets, and commuter streets. Each street designation implies an overarching vision and character that should be considered when planning specific projects. A coordination kickoff meeting is necessary to establish the scope of each complete street project and to form a project team involving all appropriate departments early in the project development process. This meeting will be an opportunity to present all team members the street context, functional classification, and initial data, as well as determine project goals and priority design elements. The design guidance of the CS Manual provides options for street designs in the form of best practices, of geometric and furnishing treatments, but in most cases it does not prescribe which specific treatments must be used in which combination. It also does not dictate which treatment should receive priority when there is a conflict between design alternatives. Rather, it gives users the flexibility to determine which overall design is most appropriate and practical in light of the goals and priorities established through the planning process and the overall policies of the manual. A matrix is provided in the CS manual to assist in guiding the selection of each element based on street context. These elements are grouped into three distinct zones: street side, pedestrian, and intersection. The matrix in Figure 3.1.6.1 categorizes each design element within each context as either essential, desired, or optional. The design team should use this matrix as the starting point to select the needed elements. For example, medians and crossing islands are considered essential for a multimodal corridor, but are optional elements for a main street. Further guidance on specific design elements is provided in Appendix A. Once the priority elements have been chosen, the process leads to conceptually detailing the thoroughfare design. As with any design process, this stage is iterative, can involve several options, and can result in potential updates to the thoroughfare plan and cross-sections. First, identify available right-of-way and other constraints such as utilities, physical terrain, and access. In existing areas, an initial cross-section of the desirable street side and intersection elements is prepared and compared with the available right-of-way. If the total width of desirable design elements exceed the right-of-way, determine the feasibility of acquiring the necessary right-of-way or eliminating or reducing non-vital elements. The design of the street side and pedestrian zones should then be completed based on the thoroughfare type and an understanding of the adjacent context characteristics. The art of thoroughfare design is balancing the desired design elements of the thoroughfare with right-of-way constraints. Higher priority design elements are those that help the thoroughfare meet the vision and context-sensitive objectives of the community. When the width of the right-of-way varies or is constrained, it is useful to prioritize design elements and develop a series of cross-section options accommodating all or many of the higher priority elements. Prior to conceptual design, additional data should be collected including current traffic, bike, pedestrian volumes, 85th percentile travel speed, survey including right-of-way occupants, and geotechnical analysis. Performance measures will help the design team evaluate the alternatives and project the effectiveness of the design elements in achieving the preferred results. Traditionally, vehicular level of service, a measure of traffic congestion, has been used for transportation planning for widening projects. However, Complete Streets project evaluation requires addressing how an alternative will serve all users. Measures that can be used to evaluate alternatives and project performance include multimodal level of service analysis, economic impacts, and environmental impacts. MMLOS is a method for assessing how well an urban street serves the needs of all users: auto drivers, transit passengers, bicycle riders, and pedestrians. The result of the analysis is a perceived degree of satisfaction for each of the four users based on three basic travel movements: travel along the street segment between two signalized intersections, travel through the downstream intersection of that segment, and travel crossing the street. The CS manual provides guidance for prioritizing design decisions for each road user based on the various street types. All of the developed alternatives are analyzed by the Complete Streets project team, comparing the various measures of performance. A selected preferred alternative can proceed to the final design stage if it is consistent with the INCOG or the comprehensive plan vision and does not have the additional requirements from federal funding inputs. The selected alternative is then further refined and given to the project team for final review. If a desired alternative does not match the comprehensive plan and MSHP or has federal funding, a conceptual design should proceed to a concept public meeting for further review. If the selected alternative is consistent with the MSHP and the comprehensive plan, then the consultant can proceed with the design. At the 30% level, a review by the Complete Streets project team is scheduled. At the 60% level, a public meeting is scheduled to receive comments on the design and make any necessary modifications based on input from stakeholders. The final design stage of the process includes developing the project budget, determining the appropriate funding source, and developing complete construction drawings. Prior to construction, city staff should take into account construction phasing to minimize disruption of businesses and residents and maintain safe travel in the construction zone. Certain times of the year may prove better for construction than others. The project team should refer to the design checklist provided by city staff. Project plans are submitted at the 90% level for final review, and then final plans are submitted at the 100% level. Well-functioning, high-quality streets are not just a product of their planning and design. The way a street is operated and managed once built is just as important as its design. For example, curbside regulations and traffic controls, signs, signals, and markings are a central factor in determining how streets operate and the quality of the public realm. The project team should stay involved throughout the implementation stage, including bidding, construction, and inspection. Once the contractor is selected, a pre-construction meeting is an important element. During the pre-construction meeting, the design elements of the project should be clarified to the contractor. Having trained inspectors available on site is critical for a complete street project to answer questions of the public and contractor. Collecting data after project implementation is important in validating the Complete Streets program and confirming the anticipated benefits were realized. Projected cost versus actual cost and before and after level of service determinations can be made. Economic benefits need to be measured over a much longer time period. Proper operations and maintenance of a facility is critical to the long-term success of a street design. Elements that should be considered to ensure the desired functionality of a street include traffic controls, limitation of vehicle access, regulation of curbside activity, cleaning, and enforcement. Curbside signage, striping, and traffic controls are central in determining how streets operate and the quality of the street design. Maintenance of street materials, furnishings, and plantings is critical to long-term success of complete street designs. Elements to be considered are listed in Section 3.4.3. MMLOS is a method for assessing how well an urban street serves the needs of all users. The MMLOS analysis methodology most commonly used is based on research sponsored by the Transportation Research Board through NCHRP Project 3-70, Multimodal Level of Service Analysis for Urban Streets. MMLOS is designed for evaluating complete streets, context-sensitive design alternatives, and smart growth from the perspective of all users of the street. It uses quality of service as an indicator of the traveling public's perceived degree of satisfaction with the traveling experience provided by the urban street under prevailing demand and operating conditions. Figure 4.3.1 provides guidance on how the various transportation modes should be prioritized within the street types identified in the MSHP. For example, a multimodal primary arterial should include transit, bicycles, and pedestrians in the street design at the highest priority, while also accommodating automobiles and trucks. Multimodal level of service scoring can be used as performance measures both during the design stage as well as part of the ongoing evaluation of the street after construction. Figure 4.4.1 assigns definitions to the different levels of service, LOS, A through F now for the various travel modes. Multimodal LOS A is best, while multimodal LOS F is the worst. A chart detailing MMLOS modal priority is provided in Figure 4.5.1. Further guidance on evaluating the functionality of a mix of transportation modes is provided. Acceptable and desirable levels of service are presented for each type of roadway classification in the MSHP. These performance measures should be used to determine reasonable accommodation for each travel mode. Modal performance of existing and planned roadway sections should be evaluated and compared to these predefined performance measures to determine effectiveness of improvements. Not all roadways in Tulsa should be expected to rate at LOS A or B. Ratings of C, D, and E may be considered acceptable in some urban settings. Higher LOS ratings would be desirable in locations with high multimodal activity. One element of a roadway cross-section that is sometimes underdeveloped is the street side design, also known as the pedestrian zone. When looking at the cross-section of a walkable community, the street side design is a critical part of design that fosters a pedestrian-friendly environment. The role of a street side is to promote pedestrian amenities that encourage growth in a walkable environment that is consistent with the context type. Street side design is interdependent with the context type of the surrounding area and other characteristics like the landscaping and the street side furnishings. When looking at both the context and the street side design, public right-of-way contains a great opportunity for advancement in walkability and community in key areas. This section will address the different approaches to maximize the context potential of the street side area for pedestrians by looking at the key aspects of a street side. The edge zone represents the area that is between the curb and the furnishing zone. This area serves many purposes for many configurations. If there is on-street parking, this zone either serves as an area to open vehicle doors, if vehicles are parallel parked, or as vehicle overhang if parking is not parallel to the curb. This area also serves as a place for parking meters and a place to access public transit. This zone is not primarily used unless for accessing a personal vehicle or public transit. The edge zone serves a purpose as a setback for the furnishing zone and also for pedestrians to transition to transit or to their motor vehicle. Transit shelters and other transit amenities may also be located within this zone. The furnishing zone is the area between the throughway and the edge zone. This zone is used for public services, landscaping, utilities, and as a buffer for pedestrian safety. Some of the many uses are listed here. This zone serves a great purpose for the appeal of a thoroughfare to motorists, bicyclists, and pedestrians. This zone also serves as a buffer for pedestrians to increase both the tangible safety and the perceived safety to pedestrians. This area can also be used for public and private features. Public features that may be used in the furnishing zone are benches, planters, drinking fountains, and trash cans. With proper license agreements, this area can also be used for street vendors, or in some cases, seating for a local restaurant. When done correctly in the right context, a furnishing zone can greatly increase the lure, walkability, and safety to pedestrians along a corridor. The throughway is located between the furnishing zone and the frontage zone. This zone serves as the travel lane, so to speak, for pedestrians. This zone is allocated strictly for pedestrian use and should be clear of obstructions that could impair accessibility for pedestrians. The frontage zone serves as a buffer between the building front, if there's not a setback, and the walkable area, the throughway, of the street side. With proper license agreements, the frontage zone can serve as an area for storefronts to advertise on the street, or an area for restaurants or other shops to utilize for seating. When properly executed, there is adequate room for shops to use the space without introducing crowding or interfering with the walkability of a thoroughfare. Now, lane width is an important aspect of design, and it creates the balance between pedestrian, bicycle, and motorist-friendly thoroughfares. In general, wider lanes are more suitable for motorists due to higher vehicle speeds and wider interchanges. Lane width design is contingent on many considerations. Width of emergency vehicles and transit buses are considered when establishing lane width. If different lane widths are to be used for multi-lane roads, the wider lanes should be the outermost lanes to encourage road sharing with bicycles. Keeping right-of-way in mind is important for design as well. Lane width is a balancing act with the available right-of-way because there are many other aspects like the street side and median that also need to be addressed within the right-of-way constraints. Bicycle lanes can affect lane widths as well as on-street parking. Both aspects increase the near side lane to account for door swing and bicyclists sharing the traveled way. Medians create a great opportunity for pedestrian facilities. One opportunity is to create mid-block pedestrian crossings. The mid-block crossing serves as a delineated location for pedestrians to cross the road in areas with long blocks from crosswalk to crosswalk, or if there's a heavy pedestrian feature that needs quick access across the road. They can have a great impact on pedestrian safety by providing a safe crossing area between major intersections. A bicycle lane is a portion of the roadway that has been designated by striping, signing, and/or pavement markings for the preferential use of bicyclists. Bicycle lanes include a bicycle pavement marking with an arrow to indicate bicyclists should ride in the same directions as adjacent motor vehicle traffic. These facilities are typically recommended for arterial roadways, streets with channelization. Shared lane markings are pavement markings that are placed within the vehicular travel lane of the roadway. Unlike bicycle lanes, they do not designate a particular part of the roadway for the exclusive use of bicyclists. Shared lane markings indicate the location bicyclists may operate within the travel lane. On-street parking has many benefits and challenges that help the overall design of a thoroughfare. On-street parking provides an area for loading and unloading of cars and trucks, which can stimulate sales at commercial retail uses from foot traffic due to the ease of access for motorists. On-street parking is an appropriate option for increasing walkability and access, but there are also trade-offs to using on-street parking. On-street parking decreases the available right-of-way for other facilities. This means that sacrifices like bicycle lanes, motorist lanes, and pedestrian accommodations may be decreased to make room for on-street parking. One solution when bicycle lanes or shared lanes are present is to use parallel parking or back-and-angle parking. This decreases the blind spot between motorist and bicyclist. On-street parking uses right-of-way that could be used for widening pedestrian facilities or widening roadways. Pavement markings in the traveled way for the designation of bikeways, shared use paths, and on-street parking deteriorate over time and lanes can accumulate debris. A good roadway maintenance program preserves the investment in striping and pavement markings and ensures the continued safety of all roadway users. The curb radii are used as a barrier between pedestrians and motorists at intersections. The curb return radius plays a large role in the length of a crosswalk, leading to the overall walkability of an intersection. In general, the larger the curb return radii, the longer the crosswalks are for pedestrians. On the other hand, a larger curb return creates a more motorist-friendly environment with higher turning speeds and ease of use that can accommodate larger design vehicles. The curb radius is a trade-off between motorist functionality and walkability at an intersection. To create a more multimodal thoroughfare in urban areas, it is encouraged to decrease the curb return radii at intersections. Using a smaller radius creates shorter crosswalk lengths, improved visibility between motorists and pedestrians, decreased severity of crashes, and a more accessible route for disabled persons. Curb extensions serve to decrease the road right-of-way at intersections to increase pedestrian safety for many reasons. The most appropriate location for curb extensions are in high pedestrian urban areas. Curb extensions should also be used in accordance with on-street parking, especially diagonal, and cannot be used with an exclusive right turn lane. In areas with bicycle lanes, the curb extensions should extend past the width of the bicycle lane. With the vision for Tulsa in place, supported by guidance from the Complete Streets Procedural Manual, all Tulsans can look forward to a future transportation system that appropriately adapts to the changing urban environment and needs of all roadway users. In developing this manual, some important lessons have been identified that should be considered during the implementation of future Complete Streets projects. For one, it's important to maintain strong interdepartmental and city consultant relationships through the design and construction process. Complete Streets planning is a collaborative process that involves effective communication between various departments, such as planning, engineering and economic development, stakeholders, the street designers, and the general public. It is important to acknowledge and address all concerns so that a consensus may be reached at the end of the process. Depending on the extent of a project, an additional opportunity for public review, such as a multi-day workshop, may be preferable to reach full agreement on the preferred design alternative. A consensus-building exercise can help reach a resolution during the public involvement process. This first involves active listening to gather public feedback on their knowledge and perception of a street. During this step, all opinions matter and conflicting ideas will be worked through. Next, conceptual design alternatives may be unveiled to generate discussion, and mixing of ideas should be allowed. After review and discussion, the participants may be asked to give their preference for an option. Minority opinions should still be given an opportunity to state their viewpoints. It should not take more than 2 or 3 rounds to arrive at a consensus. Finally, the project team should provide next steps to explain how the new shared idea would progress and be implemented. The streets of Tulsa are an important part of the livability of our communities. We can control our transportation destiny by thoughtful, context-sensitive design to serve all users regardless of ability. Serving as an example to the rest of the United States, Tulsa is participating in a movement to design and build complete streets. A Complete Streets policy resolution has been approved by the City Council and the Mayor. The Complete Streets Procedural Manual has been finalized and will be utilized for street projects in the newly approved Improve Our Tulsa funding package. We serve as the catalyst for building road networks that are safer, more livable, and welcoming to everyone.